Welcome, I'm Bill Wake. We've been working on a programming language called Tenth. It's an imitator of Fourth, and we've gotten as far as the interpreter works and the compiler works, but we've got some loose ends to work on today. I think in principle we could start implementing lots of primaries right now, but I think we've piled up some of these loose ends. We'll be better off if we do them first. Okay, I did a few things offline. We had a note to raise the data stack size. I think it was at 1,000. I raised it to 10,000. I just noted that we had already decided to ignore overflow and not worry about the biggest negative number, things like that. I rearranged the register file just to put things in groups. I didn't change the register numbers. And then I created a new asUnit.key. I'll share that just briefly. And these are just enough notes to kind of hopefully remind us, or maybe anybody else that ever reads this, but asUnit consists of some macros and some code. The macros, we have a test all that you put in the main routine for each test that basically prints the file's name, and then a test start and test end you use around each individual test. And then we have some code, an assert equal method, assert equal string, assert true, and assert false. They all kind of do what you would hope for, maybe not as nicely in the error output. And a couple of test examples. I guess this is interpreter test. I couldn't remember which one it was. But showing just there's a routine. It's got a test all before it calls each individual test method and goes on from there. And then a sample test. You test start and you put the name of the test. And you got a range act assert like you might expect in a TDD style thing. You call the routine you're going to test, and then at the end, you do an assertion that prints pass or fail. And limited details, we print x0 and x1, I think, if they fail, and I don't know, maybe you get a little bit more, I guess. Can capitalize this for consistency. All right. Where we're going to start today, well, okay, so I think the things are, one is that dictionary search, we were going through catching uses of x22 and noticed it was using x22 as a temp, and it's already got an assigned value or meaning. So I think we'll see if we can get rid of that. Then we had a question about when do we look up words? And right now we take the word you read, we say if we're in run mode, go run it. Run then looks up the word in the dictionary and then runs the code that's attached to it. If we're in compile mode, we check if you're a meta. If you're a meta, we kick you back out to run mode. But if you're in compile mode, then down in compile, we look up your address in the dictionary and store that in the secondary. And, that's sort of the subroutine call, fill in the blanks kind of thing. Now, what is common in those two is both those subroutines end up calling the dictionary. I'd like to just kind of look at them and decide, does it make sense to call the dictionary once up top, or is that going to be less helpful than calling it where it is? All right, and then we had a note, look up words before REPL tests. So if we looked up the words in the dictionary and then we staved the pointers to the words in the dictionary, we could make meta look at pointers instead of comparing strings. And next note was compiler routine. I noticed we use that register. We hold the routine in a register, but the only place we use it in the register is one test that really doesn't have to use a register. So we could eliminate that indirect call, turn it into a regular branch to the compiler, and probably simplify our test to a little, or at least change it. Next one is just a minor idea I had, but when you're asking for more text, you might be in the middle of compiling something, and I just thought, maybe a little symbol in there to kind of indicate, hey, this is compile mode, and you're still in that because you haven't typed a semicolon yet. Next, we found that we could do a relocatable address somewhere after kind of having convinced ourselves we couldn't. And so I'd like to explore whether we can change our initial dictionary of primaries to use to use relocatable addresses so we can set it up at compile time instead of runtime, basically. And then line 8 there, numeric constants. So we have the notion, I mean, we've built the code to do push so that you could put push 7 in the secondary and it would know how to interpret it, but we don't have anything that actually generates that yet. So in the code generation, usually you look up a word, it's there, you put the address, the word address in the secondary. Numeric constants, you're supposed to put the secondary address for push in there and then followed by the actual constant, which means that the process of identifying that to compile it, we have to, it's not in the dictionary, it's just a 17982, it's a constant number sitting there, and we need to figure out how to interpret that. Strings are going to have the same problem. If you're in compile mode or eval mode, if you get a string, we'd like to do something. We've not defined strings at all, and I don't plan to this week. I kind of think we'll get our primaries done or mostly done first and then think about strings. But they're going to have the same problem. If it's a string, it's not going to be in the dictionary most likely, and it should be interpreted. It should put the string somewhere and put a pointer to it somehow. We haven't defined how, but it's going to be kind of like numeric constants. And so I think we're going to tackle at least most of those today, not strings. I'm going to save that for another week. Well, hopefully next week. But this if we finish number 2 through 8 here, that would be kind of great. All right, and then after we finish those, at least as far as up, not including number 9, I want us to start implementing primaries. So we got a bunch of arithmetic ones. We already did plus, minus, and times. We want to do divide. We have not, we haven't done div. Do I need div if I've got divide? I'll have to think about that. That probably should be mod. I don't know. Div mod, it's kind of nice to create both those at the same time because usually if you need one, you need the other. Well, we'll see. And min and max and absolute value and negation. So, sort of traditional arithmetic operators, same thing for the logical ones, relational ones, less than 0 equals 0, all the usual suspects, a bunch of stack ones, pop, swap, dupe, cab, CBA, bab. The ABC ones tell the order you wish ABC was in. So it does some swapping around on the top 3 elements. And then memory, we really haven't discussed how to do variables or arrays yet, so we'll have to work something through there. Control statements, they're kind of like the numeric constant, that they involve extra work. They're another meta that has its own little stack. We did the work to make it work in the interpreter, but we haven't gotten the compiler to deal with those. I want to at least get a print to print numbers, and then, like I said, strings are TBD. Okay, I guess we'll start with dictionary search. Here's dictionaries tests. Now, the nice thing is we have done TDD, so theoretically, we don't need to, the changes we're making shouldn't change anything effectively. So in that sense, I think we're kind of good. X22. Save next word. Well, that's kind of arbitrary. So what's going on is X22. Now, we got some confusion here. And I know because I was confused yesterday. So let me pull up the red core defines. Okay, so next word. Yeah, I think next word is pointing to the next word red. All right, let's open up input. Okay, so that register points to, it starts out pointing at the input buffer, so that's where it's going to start reading next. Now, by the time you've read a word, let's find readword. Readword points X0 to the returned word as a 0 terminated string, and next word at that point is moved forward past that word. So I know I've been confused at various points. Oh, and I lost dictionary. Okay, so we want to read this, keeping that in mind. Now, X22, what did they use it for? Well, okay, let me go back to our notes. Environment notes. Okay, addressing modes, registers. So X19 through X28 are reserved for the caller. In other words, if you're going to change them, you got to push them on the stack and then restore them, which we're doing with X22. So from the sense of does the code work, it's fine. But up to this point, core defines... Did I lose that too? I really hate this. Like Xcode, if I wanted to close it, I would have closed it. Okay, we're not using X27, X28, or X29. I should probably say free. Hopefully we'll remember to migrate those if we do. But so in a sense, I think I would probably rather use one of these just because they're free temps already in our coding. Oops, just 28. In our coding standard, which is the normal ARM64 coding standard, or at least Apple's version of it. There's little differences in these X16 through 18. We're not using X29 at all. I mean, theoretically, we probably could use it as a temp, but it's there. It's there kind of so when a compiler places a bunch of variables, you can point to the start of those variables and use positive offsets and not have to keep track of whether the stack is changing while you're doing things and stuff like that. But we don't really need it. If I were desperate, I could use it. But I think we'll take X28 and use that as a temp instead in dictionary.s. Okay, so this is not really, I mean, we don't care what it is. We're just saving it. All right, so let's make this X28. Okay, X28. Okay. Yeah, X28 is just a temp register, so uses X28 temp. Well, register. X11 holds address of search string. Well, what's X11? That's a local. Caller saves. Okay, so we can't use it. Well, we're not calling anything else, so I guess we're okay. All right, so X11 is just a temp. I guess it's temp holds address of search string. X0 is 0, or it's the word address of the found entry. Okay, that sounds like what we want. All right, so assuming, well, let's let the tool do a little help here. X22, no matches. All right, so if I do a make, let's see, dictionary tests, all green. All right. So we make dictionary search, use X28 as temp rather than X22. Good. All right. And I think that's mostly just like, why would we use this thing unnecessarily? It's not that it didn't work, because it does. All right. Now the tricky one, and I'm not sure, this sort of feeds, both these kind of feed in together. Again, it works. We're making decisions about the design of it. So let's go to REPL. All right. So at some point, REPL calls evalAll. All right. Now, evalAll is the one making this decision about should we evaluate or do compile mode. So if you're not in compile mode, you must be in evaluate mode. So skip down here. If you're in compile mode, then we're going to compile. We're gonna call the compiler basically, and skip around this when we get back. Okay. So inside them, I think as I think about it, I think they are just different how they do it. So eval, it calls dictionary search. I don't think that's helpful. Compares the result to 0. If it's not found, it goes down here and does something. Sorry, branch not equal. I'll call found. Oh, if it's not 0, it's a valid routine. We should just call it. Okay, so we load the temp with. Oh, interesting. X29. I guess we're making sure X29 has the value before we call dictionary search, and then we're restoring X29 in the routine. We load the value it points to, whatever the word, we got the word address back from a found search, and so we do sort of an indirect load and then branch to it. Branch linked with a register. So register X1 contains the code to execute, and we call it and then come back and finish return. Okay. Yeah, so I guess I'm thinking the next stage, if we were equal, well, if we were equal to 0, then we probably we have a word that's not found. Well, we should at that point check it for being numeric. If it's numeric, we should just push the number on the data stack. We don't have to do any of the push stuff, the routine stuff. We just know we have a number and we can push it on the data stack for immediate evaluation. But if it's not a number, then we should do this stuff. This was that word not found handler we put in yesterday. Okay, so I don't think it'll be helpful to know that beforehand, because let's say it's a word or it's a number. We come in, we looked it up, but if it's a number, we're going to jump in here. And what if, I don't know, it feels like it's more coincidental that both of these call the dictionary. And the cost is kind of those 3 lines, 29 through 31. You call the dictionary, you check if it gave you back a 0, and you make a decision based on what to do. And if it's a number in compile, let's go down now and there. Okay, that's eval. Compile. We're also saving off X29. I mean, it's got similarities. I don't know. I mean, then I'd have to check up there. If I pull this up, I have to check up there. Oh, you got a number, and now are you in compile mode? Do this, and you're in eval mode. Do that. I don't know. I have resistance there. This maybe could become a macro. Well, I guess probably that's got to be there. Probably these 3. I don't know if that really helps. And X0 here is the pointer to the actual word, so that's the word we're compiling. I think I'm going to leave them where they are. Okay. And then, do I want to mess with the isMeta thing? Well, I guess what we're getting out of that is our scan for meta words. I don't think there's going to be that many. Like if I look here, all these, none of those are meta words. The only ones that are meta, well, we've got our colon and our semicolon. The control statements are meta. So 3, 5, 7, 9, 11 plus 2 is 13. Maybe there's one more. You're talking about a pretty short list. Even like short enough, I would mostly be tempted to do just a linear search. You know, I mean, 13, your average is 6. A linear search, your average would be 4, you know. I don't think it's going to be, I can't believe it'll be a performance dominator for us. Yeah, I think I'll take the shortcut way out, and let's just, I'm going to say we considered these but decided not to. Should we use lookup words in evalAll? No, they're too similar. Bear pointers directly. I mean, gosh, there's a little temptation there still. But it's like it's an optimization, and we're at the point like we can't write an if statement. So I think before I started optimizing this, I would probably look at some other stuff first. But on the other hand, every word pays for this. Well, it pays when we go to are we going to evaluate or compile it. We'll pay that lookup meta per word. You know, but the cost is, you know, 20 instructions or something, and it's not that high. I'm assuming you run through a loop 4 or 5 times through 3 or 4 instructions or something. So I think we're going to say no. It's an optimization. We'll defer. I think that's my fairest version of that. Okay, so these two. Now, well, this is not a lot of loose ends. We're burning through them pretty quick. All right. This one, eliminate compiler routine register. Yeah, let's look at that thing. All right, it's in the one test, REPL tests. Okay, and so we, this is kind of like, it's kind of like a mock test versus another test. You know, in a way we're plugging in we are plugging in an alternate compiler and saying, did we get called, rather than testing that we did the thing we said we should. And actually it's eval. Wait, compile. Okay. Yeah, I think we could change this test to evaluate actually compiles this word, and we just decide whether or not it did that. That feels good to me. It's not a huge cost. I mean, BLR is it's probably an extra memory lookup to do the call. So instead of calling to some fixed address, you call to a register, you take the register address and you make that, you know, I don't know, maybe it's even cheaper, but you had to put it there first. So you pay 2 instructions instead of 1 at least. Maybe I'm not sure if it's an extra memory access or not, but you know, again, you know, you've got this processor running at huge speeds. And I don't know how many instructions per click or whatever it is, but you know, I'm expecting millions to billions. I think that'll be okay. And the cost for us isn't too bad. Okay, so if So the reason we did this was compile didn't exist at this point. So there was no testing it. We just got that implemented yesterday. So I can understand why we decided to go this way. You just only ended up with one thing using it, then it's just not worth it. Okay, so we're going to want to get rid of this instruction to make sure if it compiled, though, and this is going to pull in a little bit of the work from compiler. Compile puts found word in secondary space. Yeah, this is kind of this. Yeah, actually, this test is probably very close to what we want. All right, so I'm going to paste it here. We can look at it, decide. Okay. Yeah, Control V is paste, and let me reformat it to move to the left column. You know, Control Option V or Shift Control V or whatever I'm doing. Command V is paste it the way I copied it. You know, I'm like, okay. So we load a compiler address in the secondary space. Yeah, so we're making that our secondary space. We're creating a minimal dictionary and giving it the word to find. That's down here, 1, and then we call compile, and we're making sure compile word to find. Compile word to find is the same as the dictionary search. And x0 is compile test space should be equal to. Oh, that one's a little weird. Is that test right? Usually you have to specify x1. I guess x1 is still the word to find. Okay, so x1's set here. All right, I guess that finds x0. Oh no. Oh, x1's finding the dictionary entry for the compiled word, quote 1. All right, and then the load address is checking that the word we expect is contained there. Okay, that does seem right. The only difference is evalAll instead of compile. Okay. evalAll calls compile in compile mode and checking this. Okay. So if we don't find the word here, that means the compiler did not run. Yeah, in a way it was smoke test, but I mean, it's a real thing. It's a real thing to make sure evalAll triggers a compilation in compile mode. I mean, I think that's still a legitimate thing to test. But it was just, we didn't have a compiler yet. So we put in a substitution mechanism. And I mean, this test is a little bigger than the old one because it has to create its own little dictionary and stuff. But eval calls compiler in compile mode. Okay, but I think it's a good test. Now, whether it'll pass or not, I don't know. I probably should update this word up here. Eval calls compiler in compile mode. Okay. And we'll make... All right. Why? Well, let's see. There's probably some setup that's missing now. Let me compare. All right. So it was here. Where? No. Yeah, REPL test. Load address. Oh, yeah. Certainly that. Okay. REPL tests. Okay. I'll just paste these 3 before the secondary space. All right, compile routine, we don't need that one. VSP, I don't think we need that either. So we don't need that one, but it's got to be put in compile mode. That makes sense. No, Kara, may make sense, but all right. Let's check all these, make sure they're all, no, okay. All right, I'll do it the quick way. LL REPL to bad access, unknown opcode. Well, that's not very good. What line are we on? I don't know that opcode either. Long XFE 8. .016. We're in memory somewhere. Load address eval test stack. Okay, so it's memory aligned. It's just stuff. Okay, let's break in our routine. Run again, make sure we get there first. Okay. Eval calls everything. Okay, we skip over these. Next, that's our prologue for asUnit. Okay. We load, well, that's a load address. VSP is test stack. Okay. We store 0 there. All right. Move flags to compile mode. And then we load x25 secondary space with lcompile. Okay, step. Dictionary init. I'm going to do a next over top of that. All right. Store. Oh, dictionary header. I don't remember what's in there. Presumably it's putting some instructions. Step. Store. X3 gets 0, X4 gets 1. Okay, that's got to be part of that. All right, we're storing something about push 1. Okay, I guess that's still header stuff. Step. ADRP. Okay, load address x0, compile word to find. That's got to be that. Compile word to find. 160. Okay, let's step rig read x0, step rig read x0. Okay, so he's 104.160. Okay. We're going to call evalAll. Well, I'm kind of presuming that's going to be what breaks. Yeah. Okay. Okay, there's call in run mode. Okay, we'll continue. Call compiler in compile mode. Continue. Now we're in evalAll. All right. REPL. Oh, yeah, we didn't set this anymore. Okay. This should just call compile. Okay, well, we're doing TDD whether we realize it or not. Compile. So BL, because it's still a subroutine call, but he's going to compile, not the register for it. Okay. All right. Well, that's good. That's how it's supposed to work. All right. Yeah. No, I think that compiler routine argument, the register was just full of junk, and it somehow tried to jump in there and blew apart. Okay. So our find, we still have this. Yep. Okay. We don't need this anymore. Because we're calling it directly. We don't call a routine. So let's move x23 down here. All right. REPL, BL compile. Compiler routine is compile. We don't need this anymore. All right. And then this, that's not there in the first place. Okay. Let's make... Okay, good. And we'll make REPL just to make sure we haven't messed anything up there. 1 colon add, no, colon 2 is 1 dupe add semicolon. Okay. And if I call 2, I should get top of stack 2. And if I add, I should get 3. Okay. That's good. Okay. Eliminate compile routine register. Yes. All right. Make readword prompt print copyright C for compiler when in compile mode. All right. That's really a manually tested thing. That's in our, well, I can't remember if it's an input or somewhere else, but let's find prompt. Okay, print prompt. Yeah, I don't think I want to I'm not going to try and test this automatically. I think I'll just do it. Yeah, it's a little weird. I mean, 1 is that same thing. It's a dictionary entry. I think it's something you can do to yourself, but it is confusing. You probably shouldn't do it to yourself. I don't think I'm going to enforce it. Historically, the 4th has allowed it. Again, whether it's a good idea or not, I don't know, but I'm not going to try and be stricter than they are. I'm trying to be a little looser than they are. So, all right. Anyway, prompt. We know how to test flags because we do it in REPL, where we just were over here. Okay, I'm going to close this. REPL in evalAll tests the flag. So it's really this kind of code that tells if we're in compile mode or not. And so I'm just going to import that. See, Shift Option Command V. Please don't screw with my stuff. Okay, and this thing with compile mode. If we're not in compile mode, L print prompt. Here. But if we are in compile mode, we're going to do something x0 with L compile prompt and BL print. Okay, and up here ASCII 0. All right, let's put L compile prefix, probably a better name. ASCII Z option G. Yep. Okay, and I changed the name, so I better change it back down here. L compile prefix. Okay. So are we in compile mode? Okay, I think that'll do it for a comment. If we're in compile mode, well, check the flag. If the compile mode flag is on, if it's off, then jump down to print prompt. If it's on, then print the prefix character and go. Okay, so let's make REPL. Oops. Compatible register or logical immediate. That sounds like a... Oh, we defined those somewhere. REPL probably. REPL.macros. Okay. Compile mode. I think that's okay. Okay, colon add one is one, well, dupe one add. Okay, so x plus one goes on the stack, x gets retained, and if I don't hit semicolon, I should get my prompt. Yeah, it's not the best prompt, but it looks different, so I'll give it that. Dupe one, add semicolon, one, add one. Should give me two on the stack, and then add should give me three again. Okay. I think that'll help a little bit. I'm sure I'll be confused by that at least once. That I forgot to close the semicolon. Okay. Not sure. Oh, I guess I did both those. Yeah. Yeah, I think I'll leave the visual C as being enough, but maybe not. No, I think that's a nice idea. Let's do it. All right, let's check this in first. So I did two things. One is eliminated. Well, no, I better look and make sure. I may have done three things. Oh, did several things apparently. Okay, we did the prompt thing. We switched the compile routine. Okay. multiple steps. All right. Oh, let's see. We know how to do that because asUnit does it. Right. So green, I think green is good enough. Input. All right. So now I'm going to make this do the whole thing. All right. So that is there. Well, I want that on this one. Bracket 0M, okay. And then this one, we want red, wherever asUnit got to. Fail. Red, and then same ending. Well, I guess the space can go after. Yeah, you're right. That'll be a better visual indication. Okay, make REPL 10 in green, colon, add two, dupe. Oh, yeah, I haven't broken that apart yet. Okay, dupe 1, add semicolon. All right, I did want to make this an else now. L. Compile prefix, L compile prompt, we've changed it, and L run prompt. I still haven't done that. Huh. Okay. All right. If it's this, then we're going to branch to L reading, which is down here. Try again. Yeah. Should get a 2. All right. Yeah. I think both is good. Because if you're colorblind, red green won't tell you much, but a little C there might make you go, what? That font's not so great for that, but I think the red and green are nice. It's kind of a warning mode. Deserves its red. All right. So that's good. We didn't do a make, I don't think, on that last one. All right, ACP. Print prompt in green for compile mode, red for, oops. Green for run mode, red for compile mode. All right, can we use really locatable addresses? Yeah, I considered that too. I kind of want it to be the default in a way. I don't know. Maybe that'd be all right. Um, Option R? Yep. Oh man, they're ugly. Ah. It's got a it's super scripted. Let's see, is there we might be able to find a circle R emoji symbol thing. This takes forever to come up. And when it does, it's on the other screen. I also thought about a little running man. I don't know if that's a dingbat or not. Skiing man. Yeah. Okay, let's look for R. And there's this. Okay, I guess that's acceptable. Oh, well that's even, oh, that's so weird. Yeah, I don't know, maybe a running man would be cute. I know the beta, SF beta symbols have it. SF symbols. Yeah, there we go. Running right. I was hoping for a more abstract one. Oh, it's going to be so hard to read at a small size. Okay, no, I think I'll switch the C back to a bigger one and run with that. Well, that one looks, yeah, that's nice. Okay. Okay, so that was the input. I'm going to go back and close everything here somewhere. Okay, prompt. I don't know, would a space there help? Yeah, that is kind of worth it, isn't it? Yeah, I like it. All right. Colon word. Yeah, compiling 10. Dupe. Semicolon. One word add should be 2. Oops. Oh, word not found. Oh, yeah, okay. Well, gotta put your spaces in. All right. Well, there you go. That warned me, like, hey, it kind of screwed it up, but now I know. All right. Run make, just to be careful. Okay. All right. So now relocatable addresses. I don't know. I kind of feel like the relocatable addresses, we've already worked around them. So in some sense, they're not as necessary. Whereas numbers, so we don't have to redefine our own dictionary definitions for numbers. Oh, you want 17? That's 4 times 4, 1 add, 4 times 1 plus. So I think it's a bigger step to do the numeric constants, but I guess if I had to choose how to end the week, I would choose that. I think we'll do both, but that's okay. I'm going to move this down. He's down there, down by ideas. Okay. I guess I could put this down at the bottom of the groups too. Numeric constants. All right. Did I check in? Yes. Good. All right. So the way they work is if you're in eval mode and you see a number that's not in the dictionary, you see a word not in the dictionary, and it's all numeric, in eval, you should evaluate that number and push it on the data stack. In compile mode, you should pretend the word was _push that thing's word address, or copy that word address into the secondary area, copy the constant value into the secondary area. All right. Well, okay, I'm closing everything. So, right. So this really is on REPL still. REPL. Zoop. Okay. And REPL test. All right. And let's eval is probably slightly easier. Okay, so I think either mode, it needs to convert the string to a number. Yeah. That's where... Well, we'll certainly... Oh, we have deck to string, right? No, we don't have string to deck. All right, so we'll have to do string to num or something, Right. So maybe I mean, X29 is our word. We have that regardless. So if it's not found, my assumption is we're going to put code in here between 31 and a half, as we say. And that code will check if the thing's a number. If it is, it's going to push it. Otherwise, it'll fall into this error case or jump to this error case. All right. I'm going to flip these first. I don't know. I find it annoying, but so lcall found does its thing and goes to eval exiting. This thing does its thing, goes to eval exiting. So if I change this to EQ and move this down and move this up, okay. Drop these. This is L. Word not found. Okay. Whoops. All right, I may have used that somewhere else, so we'll have to compile and make sure. Doesn't make much. All right, so this was REPL tests not affected. Good. Okay, so I All right, so this case is handle a known word. All right, make ICP refactor swap branches for word not found in REPL. Whoops, that was it. Eval. Or it could be string to number routine that fails. Yeah. Yeah, and it's also a fourthy kind of thing to not handle negative 1, 2, 3, and you use 1, 2, 3 neg if you want to negate it. All right. Yeah. So I think that refactoring that doesn't change anything, but we do need some sort of numeric thing. Now we could. I mean, we're after the positive numbers, so we could make it negative to mean like it failed. I think we have a 0, don't we? Did we? Maybe we don't. Yeah, we don't. Okay. You certainly could. Although, well, 0, 1, they're very commonly used. It might be worth having a special routine for them. But we can't do them all. We won't do them all anyway. Yeah, so, I mean, So if I had string to positive, maybe just string to num. String to positive would tell me like something's going on if it's not positive, right? So I think that's maybe the way to go. And okay, so, and I would call that a C-like thing. I don't know why it keeps closing my folders when I bounce around. Tray annoying. All right, and then C-like tests. Yeah, so, boy, as we get this thing longer, I'm starting to think maybe these should be separate files too, by the way. String length, string EQ, string copies E, deck to string. And now we've got string to positive. This is gonna get, well, see, like, we'll have a few more, but not a lot. I guess I'll just live with it. All right, so BL string to positive converts positive, and then BL string to positive returns 0 if not number. Okay. I'll put both these down here. Oops. Okay. All right. So we're going to need some data. So, I don't know. I guess we'll just, we're taking ASCII Z 1, 2, 3, 4. This is L positive string. And let's make an L non-numeric string. Okay. I don't know. It's a little, it's hard to know how to do this best. I don't want to introduce exceptions. All right. And then we have to do a line to here. Okay. Well, okay, let's just do it. Load address x0 is L positive string. String to positive. Okay, well, I guess we want to say x0 is whatever comes back. So move x1 gets 1, 2, 3, 4. BL assert equal. Yeah, maybe that would be a good way to do it. I don't know. I mean, we're going to want to check x0 for number. Yeah, I mean, the calling standard is one return value return an x0. But I mean, there are languages that have multiple return values, and they could, you could certainly change the dynamic there a little bit. I'm gonna stick with 0. It's a little bit overloading the range of this, but I'm gonna be expedient, I think. It's not a bad thing to have a 2 return values though, because that's sort of becoming more common. All right, I'm going to assert that it is 1, 2, 3, 4, and this I'm just going to return for now. And this better be in C-like. Okay, so that should just do nothing at this point. I probably can comment string to positive. Returns positive integer or 0. Input x0 equals pointer to string to 0 terminate string to check. Output x0 equals number if valid, 0 if not a positive integer. Okay. And this test should fail. The last one should pass just because we haven't done anything to it. Okay, we should declare that global. Zero to positive. All right, this doesn't have any assertions, so it has nothing there, but this returned random garbage instead of 1, 2, 3, 4. Okay. Well, I'm not going to worry about overflow. Because we decided to be lazy on that, or at least I did. I won't blame you for that one. Okay, so the result, we're not going to have to call anything else. We just have a bunch of numbers, and let's subtract. Well, we need a result. Okay, so let's set x1 is 0. We'll move x0, move that to x0 at the end, but that's going to be the sum. Okay. Okay. So if x0 points to the string, we can modify that. So x0, well, we're going to load byte. I guess W2 with contents of whatever x0 points to. Do I want to post increment here? I don't think I can yet. All right, and this is L str2 pause loop. Okay, so we get that character. If that is 0, if it's 0, we're going to branch to L exit. Okay, and then if it's not 0, well, here's L exit. Move x0 gets x1 and return. Okay. Well, load a byte. If it's a 0 byte, we're going to exit with whatever we have because it's been safe so far. Okay. So now I want to take well, I don't know, one of these tricks, not a trick exactly, but one way of doing things. We'll subtract W2 gets W2 minus 40. Okay, so 30. 3 times 16 is 48, which is the character code for 0. Well, I'll use single quotes. Okay, so W2 is hopefully in the range 48 to 57. And we're going to shift it to the range 0 to 9. Okay. And if all right, now I think we want to, is it CMPU? There's a compare. So we have to decide if it's in range first. So we know it's not 0. But I know there's compares. There's like a compare unsigned. We want to make sure it's physically less than 9 or less. And if it is, then we got a 9 or 7 or 3 or whatever sitting there. And yeah, we'll multiply and add 1. Okay, but compare. Well, that's pretty good. Compare negative. No, we want just compare. Compare value to immediate. Well, actually, it's like b dot any. Let's see where that's defined. There's a table somewhere. Come on, guys. branch dot. Not that one. Okay, well, that was the awkward way to get there, but that's what I want. Okay, we want b dot greater equal. Okay, so if it's W2, no, it's not a compare. I want greater equal. I want unsigned. Unsigned higher. Okay, we can work with that. Or unsigned lower or same. Unsigned less than or equal. Okay. It's allowed to be a 0 if it comes after another digit. It even is beforehand. I'm not going to worry about, I'm not going to make it octal or anything. I'm just going to make a string of digits. All right. Compare W2 to 9. All right. So if it's equal, well, let's see. All right. If it's less than or equal to 9, then I want to go back to my loop. I want to increment and go back to my loop. Oh, wait a minute here. W2 is my, X0 is my counter. Okay. Maybe this, because we loaded the byte. So I think I can increment X0 plus 1. Right, because W2 is sitting there. We got that byte. All right, I think that'll help. A branch dot, and what was it? Same or ls, lower or same. Okay, if it's less than or equal to 9, well, I guess if it's greater than, then we've got a non-numeric. And I'm going to move a 0 to x, move 0 to x1, right? And then x0 gets x1. We may be able to smooth this out. Yeah, well, that's the nice thing. That's the trick of using unsigned comparison. So if it was less than 0, let's say we had 20, okay, it would turn into a number bigger than 0 in the unsigned sense. It'd be negative 1. Let's say we took whatever's right before 0, OX2F, okay, whatever that is. That thing would not be less than 9. It would be negative. So it would come out as looking high in the unsigned comparison. And I might even highlight this. Unsigned comparison. Okay. GT. Make sure I'm saying this right. Signed greater than. That's the wrong one. High. B dot high. Okay. So it's a little bit of a trick, like I said, but we're making sure we've shifted it so it's in the range negative OX30, or yeah. So if it was 0 and we subtract 30, it goes to negative 30. So it's going to become in the range negative 30 to plus 255 minus 30, 225. And looked at as an unsigned number, that's going to be greater than 9. You know, only 30 through 30. 9 will be less than 9. Okay, high is unsigned higher is greater than unsigned greater than. I'll say it that way. Okay, so if it's greater than 9, we're going to jump down to non-numeric and get out of here with... Actually, I'm going to leave this out. I'm just going to exit. Okay, because we haven't written that test yet. But now we're here. Now we're ready to do the multiply. So we take multiply. Well, actually, I think there's a multiply add instruction. We'll just be little clever people here. Mul add. Oh, floating point. Floating point. Oh, it's only floating point. Okay, well, we can live. All right, so we'll multiply, and our gathered sum is x1 equals x1 times 10. And then we'll add x1 equals x1 plus w2, x2. We'll go back into the signed whatever domain. But we know it's between 0 and 9 unsigned, which means it's between 0 and 9 was signed. Yeah, too bad we're not doing floating point. All right, so now we've computed the new sum, and we can branch to else to pause loop. Okay. It's a lot to, I mean, it's not a huge amount of programming, a real programming language, but, it's 10 instructions here. All right, so line 189, we set the sum starts at 0. We load the byte into W2. We check if it's 0. If it is, then we've run out of characters and we're fine. Okay, so whatever's in X1 is perfectly adequate. And we move that to X0, so it's a return value. All right, then if it's not equal to 0, then it's not a 0 character. We're going to subtract character 0 from it to get it in the range minus 30 to plus 225. We'll look at it as an unsigned. Compare doesn't care. It's the B that decides all that. Look at it as an unsigned. Compare it to 9. If it's higher than 9, then it's not numeric, because negative numbers look really big and positive numbers bigger than 9 look too big. All right, and then we know we're safe. We finally do the real thing, multiply our sum by 10, add the second value. And yeah, it really seems like a couple extra instructions. And then go back to the top of the loop. 192, we did the #1 at the end, so it's moving forward step by step through the X0 loop. And eventually we'll terminate when it's to 0. Okay. This is supposed to pass. Okay. Yeah. Multiply x10. Oh man, we did a multiply. Where's our core? Mul. Oh, I guess it's only. I guess it doesn't have room for that. Okay, well we'll have to load a 9. I guess good old x3. X3 gets 10. We'll multiply by x3. I mean, it really is kind of too bad to have to do all that, but oh well. Okay. And I guess this instruction can be early too. That's a handy constant, our base. X3 is 10, multiply by 10, add whatever. Okay. C, like, where are you? Okay. String converts positive. Okay. It's weird, I'll give you. But I don't know why multiply should be such a picky instruction. Let's get back to the normal integer instructions up here. Section C. Yeah. Okay. So if we find multiply, load store multiple, that didn't work for us. Arithmetic. Polynomial. There may be an instruction. I'm not going to go to SIMD for this. I think our page was like 300 something. Oh, there's the C's. Oh, table C1. All right. No. Multiply and divide. Okay. Multiple. Oh, we have mad. All right, let's see what we got. And there's multiply 808. Multiply add takes two register values, adds a third register value, and writes a result. What's WA? Just third register for holding the addend. Okay, so it equals XD equals XN times multiplicand XM holding the multiplier. Okay. It looks like we still have to keep our 3 there, but I mean, our separate register. But it can be done. All right. We didn't do the mad instruction. Mad. X1 equals X1 times X3 plus X2. Now you're talking. Okay. I guess that's still supposed to pass. I forget what I was looking up though. Multiply. Oh, we couldn't do the pound 10. Yeah, but I'll take this. It's cooler. I never used a multiply add instruction before. All right, so there we are. We pass still. All right. Make and commit. String to positive works for positive integers. All right. Well, we'll come back. Let's take our break, and we'll come back and handle the non-numeric or not all numeric case. And that should do it for this thing. All right. See you in 3 or 4 minutes. All right. Yeah, I'm going to call it Mad Dog, MADD. And then you pointed out the multiply is really always a mad instruction, mad dog instruction. So I guess I have been using it before, just didn't know it. I've been speaking prose all my life, you know. All right. Let's go to our next test. So that one went pretty well. Nice, simple test anyway. This one isn't much bigger. Instead of L positive string, though, we want a non-numeric string. And notice I'm throwing in a character at the end, so just so we can get sucked in if we, I don't know, if we terminated on a non-numeric or something like that. Okay, so if we load non-numeric, and I want this to be 0 at the end. String to positive is supposed to return a 0 for a non-numeric, not all digit string. Okay. However, this test will pass because it'll get 2, 3, 4. Okay. So yeah, 1, 2, 3. Okay. 1, 123z. It thinks it's 123. Right. So it would be interesting. Let's just do this. I'm curious what it'll do. I think it should do the same thing. Huh. Where's C like? Return 0 if not number. Okay. Yeah, so maybe that's a better test. Let's make sure this one. Oh, well, he chances to pass, I guess. He looks like a number, but he's not. Maybe we need to test both ways. Okay. So if it starts with a number, well, if it starts with a non-number, it's going to exit. I guess it'll exit as soon as it finds something that's not a digit and think it's done and have that sum. All right. So this one passes kind of by chance. My first case was a better case. It detected the failure, but let's make it 1 and 2. Let's test both ways, just to make sure we don't get one of these, what do you call it, flickery tests, you know, where you make one pass, the other one fails, and that kind of thing. Okay, so, oops, I'm going to duplicate this test. If not number, the first one starts numeric, and this one starts alpha. Okay, so we need L non-numeric string 1 and 2. 1 and 2. 1 is numeric. Let's call it starts numeric. Starts non-numeric. Returns 0 if starts alpha. Okay. Starts alpha, starts numeric. Okay. Why did it pass when the first one was 0? Because the result was already 0. It's a weird thing. Well, the sum it computed was 0, and that it never extended because the first time it saw a character, it's like, oh, out of range, I'll exit. But that's the code I kind of didn't write here. I started to write it and then took it out. So we detect the non-numeric case, and we really should say, hey, I noticed you had a non-numeric, non-zero byte character, and force that to 0 regardless. But before it was a fluke, yeah, because the sum, x0 that we're accumulating the sum in, was already was 0. So, I mean, another case would be, 1, 2, 3, Z. 123Z123 or something, you know, like you could imagine something that bowled through all the characters and didn't think to check them for type, I guess. All right, this should have one failing test though. Let's make sure that's true. See, like, yes, 123X comes back 123 because we just took whatever was in the sum, didn't talk about the status of that thing. Yep. But I think this solves it. We know we're non-numeric. We found a character that was not in range. So we force X1 to 0 so we can move the sum, move X1 to X0 at the end. A little awkward. Now maybe we can get around it. Well, let's pass our test first and then refactor. How about just for variety? Okay, see, like, yeah, so all those are passing now. Let's check that in. ACP string to positive returns 0 if not all numeric. Okay. And then the switch around I would say we could do is let's immediately let's use X0, let's copy X1. I'm going to, well, I'll tell you what, I'll do it in steps. Move X4 gets X0. Okay, so now I'm going to use X4 everywhere I use X0. I think that's it. Okay, yeah, so now I'm using X4 there. X1, I'm going to change to X0. X0. X1 goes to X0. Gets X0 times X3 plus X2. Okay. So X1 goes to X0. Right. So now X1's not needed. So I think this should be the same. We save X0 to use for the walkthrough, and then we switch to using X0 for the final result. And then when we change that status, we're not copying it over to X1, so we can copy it back to X0. It does have one extra register copy, but we're just doing it up front. Yeah, I think that should be okay. Yeah. String to pause return 0 starts alpha. Yes. Okay. Right. I guess we refactored slightly. In string to positive. Okay, now by pure chance, right? This is now exactly what we need for eval. All right, I'm gonna change these a little bit to have them in. Okay, so if the word is not found, we go down there. What I think is going to happen is we're gonna put some code in here to check numbers and then have another branch. Yeah, checking a conversion. I mean, yeah. It's very custom code, put it that way. And yet it's something we always chase or fight, right? I mean, it's the whole reason exceptions got invented, to prevent this kind of well, we're encoding the result status in there with the result value in the same single word, because we knew we had half the possible values of an int are or negative, and half plus 1, I don't know, half plus 2, half plus 1.5. We knew we had the space to keep that bit in there in effect. But yeah, so it is cheating. Yeah, it kind of is. It's certainly kind of a weird overloading. Just like read in Unix, right? Yeah, it saves a few instructions. Read in Unix, you get either the count of how many characters did you read, or you get a negative number that means like, oh, something blew up funny, And again, it's not the best way to do things. I mean, in an OO language, we kind of try and break out types, so it's very explicit. I think Swift is very nice with those fancy enums that give you the disjunctive types. It's A or B or C, kind of thing. I mean, this is either a success with a value or it's a failure, and we're encoding that in one number instead of, like in Swift, we'd probably want to encode it into a little enum. All right, let's see. So REPL tests, I guess what we want to do then is eval, if we give it a number, 1, 2, 3, we should find 1, 2, 3 on the data stack when we finish. All right, so let's find a, I guess, core test. What do we have? Colon, semicolon, dupe, or let's find this. Okay, so we create a test stack. We'll pull that in. I'm not going to use this exactly, but just to get a shape. evalAll, 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 eval. Okay. All right. So we want to test just a eval pushes number on data stack. Okay, and let's find that push test stack. It's got to be up here somewhere. Data. Oh, yeah. Okay. Right. Okay, so we've got some stuff there. We push. We set our virtual stack pointer here. I don't know what this is doing. L data. I don't think that helps us any. Okay, what we want to do, we also need a string. ASCII Z. Three, two, one. All right, we want to make an empty dictionary. We got the test stack. Well, we're pointing to this value here with nothing written in it. We don't want to care about that, but okay. So if I guess I want to do a load address. X0 gets I don't think we have to worry about space or new line because readword will read everything up to the space or new line. So we should get just a plain old C string, no leading or trailing spaces. Okay, so we're going to load our string, whatever I call it, numeric string. Okay, and man, here. All right, clear the dictionary. I guess we can do that first. All right, I don't know about this stuff, but that is critical. All right, and then act. The big thing we're trying to do is eval. And what we expect, assert. Well, I guess we want to make sure that L push test stack. Let's load that contents. It should be 1, 2, 3. Oops. Move x1 gets 3, 2, 1. I guess pound 3, 2, 1. Okay, we're loading this. Let's load it in x0. That's the address. Load x0 gets the contents of the address. Okay, so basically the first cell in our test stack, we started off pointing at the empty cell, the first cell there. It should be 0. The virtual stack pointer points here, unused. The operation of saying to evaluate a numeric string should push its value onto that stack. And so when we look there, that is the top of the stack. VSP points here, but we don't really care about that. That's not our problem. Okay, now I don't know if I'm missing anything setup wise. I've got an empty dictionary. Okay, let's see what REPL wants. Eval wants. All right. X29 is a temp. Okay. Uses okay. All right, so it calls dictionary search. It should hit this, say it's not found, come down here, and then call our global handler now. All right, but I think we're okay. I didn't call the test. Core tests, right? Where'd it go? REPL test. That's why I can't find it. Eval pushes number on stack. All right, this should fail. With our global error message about things. I'm not seeing the failure. REPL test. Oh, it just dies in there. Okay. I guess that's possible. That sort of says we didn't see an assertion, though. That seems not quite right. Eval pushes number on stack. Oh, I did not, in fact, call assert equal. Okay. Right. And I always mention Ted Young because he's the gung-hoest person I know about making sure your expected failure is exactly what you thought it should be. and maybe taking some effort to improve how it looks if it's not clear enough. But I do expect, I think we put it in red, right? Some red text saying something's wrong. Okay, now that's still not quite what I expect. I did expect that assertion to fail, but I also expected to get a warning from our global word not found handler. So let's take a look what's going on there. So I would have thought we should come in here. Oh, we didn't set this up.
I've got one pleat stitched on my kilt.
Huh.
When I get back, I will show you. Well, yeah,
we probably should set that up, and that's gonna be on. I think that's in Maine.
That's right. When I get back, I'll show you what it looks like. You'll love it. What's my mother doing now?
Where's that global? Load address X0.
Oh, good for you.
Where's this thing? I mean, we want to use it, so let's. Even though we're going to assert that it's or check that it's not there. Okay, load address X0.
It's really no good for anything. Okay.
Let's see what we do here. Load address global word found.
Oh, no.
I would have thought I had to write something. Oh, I do. Yes. Okay.
Okay. So do we owe you anything for that?
I think we can make this better.
All right. Well, thank you.
Okay, this thing, where does it exist? Here.
Well, sure. Well, I mean,
There. That. Okay. I think we could make that be our one that we set up in Maine. Word not found error. I think we could default to that in REPL. If our relocation stuff works, right? So here's another little test of relocation. All right, so I expect our error plus some sort of global complaint. Didn't get it. Okay, let's debug this thing and see why we're not getting there.
Did you get that pleat done?
Eval. No, we want to break it our test first. Okay, run. All right, and then break in eval. Continue. All right, where are we? We're in eval. Okay. Now, I think this should go moderately straightforward. All right. Until we get to that dictionary search, that's probably the first interesting moment. Okay, so we'll step, skip over this. Rearranged X0 should be 0. Okay. Step. And now we're at 38 DC. Yes. Okay, so we are at word not found. Move X0, X29. All right. Now. Load address X1, global word not found handler. Okay, I guess we want to see. Let's get it loaded in and then see what's going on there. Read X1. That should be the global address handler. Should be global word not found handler. Okay. And then mem read minus C100. This 0138381C. 381C. We didn't see that, but I think we can in our code. We're in REPL test.out. REPL test.out. Okay, so I'm looking for 381C. 3E D G 38B 381C. Okay, this is not anywhere useful, is it? C. Well, I don't know. That doesn't look like where I thought it should be. But somehow it doesn't do anything. BL assert equals. That's after 14181C. Oh, that is a real thing. Okay, that's here. Store. Compile puts forward into secondary space. That seems like it should do something. All right. I'm going to step. And now X1 should be 381C. Compile puts found word into secondary space. That doesn't seem right. And I don't know how much to worry about it, but it does seem funny. Address P. Compile puts found word. Oh, plus LXE0. Okay. And then string copy. Let's find that global handler and see what he's really up to. Almost near the bottom. There it is. Word not found error. Okay, that's right here. Standard prologue, X29, X0, word not found message, print, print, print. Okay, so let's make sure this looks like it has 3 prints. 381C. String copy. Oh, I would expect 3834. Okay. Does it call it or keep it just in case? No, it should have called our routine if the relocation is right. Now, I'm thinking maybe it's not. Because I thought we tested pretty hard to see if it really worked. But, okay, so here's the deal. We have global word not found handler is the address of the routine that you should call. So, in production, main sets that up with word not found error. Okay. And notice I put word not found error in there to try and be the relocatable address of word not found error. It's so close, though. That's what's confusing to me. The tests do this. They shove in their own handler and make sure that it's being called. All right. I may be worrying over nothing. No, this should be in run. Well, okay, good question. Yeah, we should check that too. We really do need to initialize that. It's funny, as we get more implemented on our compiler, we're able to use it more and more for tests, but it requires more and more that we have the full setup for it. They're almost becoming more, not exactly integration tests, but I don't know the right word for it, I guess. It's sort of like a little custom test framework in our setup. But yeah, let's look at these tests and make sure. Well, no, we were calling eval, so we broke it eval, so we are in execution mode. Yeah, I don't know what's going on. I mean, it gets through it. So, and honestly, it's the wrong behavior. So I think we have enough to drive what we want to do. All right, but let's run our REPL once. Okay, if I say 10, well, 100. All right, I expect word not found error. Okay, and I get it. So whatever's going on production there is finding it when it doesn't have it. Now the question is, why is our test not triggering that? And I think this, let's put this in our test. I don't think we need to keep it there, but what are we doing here? Calls eval, no. Eval pushes number on stack. Okay, that's down here. Eval pushes number on data stack. Okay, so if I do a little more setup, load the global handler. Let's call load well, what did we call it? Word not found error. Okay, so I'm making this thing explicitly overwrite the global handler. And I'm hoping this makes my test trigger that global handler. Yeah, okay. There it does. No, I don't think I'm suspicious that relocatable is not really working in general. Like maybe it'll work within one file for some reason, but it's not working, I don't think. Sorry, I should say, my theory is relocatable did not do the job, and I don't know why or why it seemed to work in that other case, but I believe this sort of establishes that whatever was in there before did not do anything. And yet when I stick what seems to be what was in there, it's not, it didn't do this. Okay. That seems unfortunate. Well, it's not the problem. I mean, we're not trying to solve that problem. We're trying to solve, does eval push a number on the stack? Okay. And the side effect I expected was word not found error. Now we can see it because I forced the handler to have the true production handler. But our goal in this test is to get rid of that. Well, it's to make it not get a word not found. It's supposed to push that data on the stack, which it's clearly not doing yet. Okay, so I think we will chase that down. I've got it on the to-do next. Relocatable addresses elsewhere. All right. But for now, I'm going to leave that way, and let's make REPL do the right thing as far as eval. Okay, so word not found. Well, then we want to check for numeric. Oh, I don't have to say check here. I think I'll just do the check. All right, so I'm going to say move x0, x29. So I'm getting x0 back to my starting word. I'm going to call string to positive. Okay. Compare x0 to 0. If it's equal, word not found. I'm going to move that label. Okay, so that. And then eventually I'm going to be eval exiting once I've done the right thing. Okay, so branch word not found. Now this needs to be up here, word not found. Now this should be check for numeric. Okay. Oh, yeah. Handle a known word. Now here is handle a number. Okay, we'll do the stuff we'll call exiting. That gets us out of here. Okay, so if it's a number, then x0 is the number. Oh yeah, that's a good question. If there's another test that messes up the handler. So yeah, that's a possibility. All right, handle a word. We got x0. We just want to do a push of x0, and we have something for that. Let me get. Is it assembler? Data push. Okay, so we can just do a data push. x0. Okay, and so x0 is the positive number. It's not 0, so if it is, we branch out. Well, handle, I could say a little more specifically, push the number on the data stack. Okay, eval exiting. All right, I believe this will solve both problems. No longer trigger word not found and get the right assertion. Okay, what do I know? Eval pushes number on the stack, word not found. Question YA. I assume that's the translation of 321. Push the number. Okay, so x0 is x29 should be the word that comes in. We saved it here. Call dictionary search. If it's 0, check for numeric. Okay. We're back. X0 is the word. Oh, X0. No, X29. Nope, X0. Start with the word. Check it for being a positive number. If it's not, bug out. If it is, push the number on the stack. Yeah, that's a good question. Why that would be. All right, I think we'll run the debugger on it. Was there anything else that should happen? I don't think so. Normally we would execute the code. Now we're executing the number. Otherwise we'll call our global handler. Restore x0. Oh, I do here. Well, yeah, that's a really good question, isn't it? Okay. No, I think you're on to, well, I mean, I did put it back, but since I did put it back to whatever came in, that should be x29. We store it. Oh, we didn't restore it. So as people say, okay. I mean, I don't know if that's the problem, but that's a real... Okay, question 9G. Question 9 question. Is pointing off somewhere. Who knows where? Comma T. Okay. Interesting. It's like X29 got destroyed. Does this thing use it? Just as a question. It does, doesn't it? C like is positive. Hey. No, I guess he doesn't. Huh. All right, let's go in debugger on this. I want to find the right test, and then break into eval and see what's going on there. Something's very suspicious though. Although this part is right, so we're pursuing something a little off the track here. Well, it's not. It should be corrected by now. It's not. So this is definitely a problem. LD REPL tests. Break on there. Run. Break set -b eval. Run. No. Continue. Okay. We're in eval. X29? Yeah, because X29 is that's a callee save register. So the caller gets to assume it's not been destroyed. And so if you're going to destroy it like we do, then you're obligated to restore it. Now I'm going to go back to environment. X29 is frame pointer. That's a really bad choice. Let's change this to X28. 28. Again, I don't think our stuff is doing anything that would affect it, but frame pointer is sort of it does have a meaning to this, to the runtime environment in general. So I think it makes a bad choice to use. If I were desperate, I would use it, but I don't want to. Okay. Let me change this or rerun this. Yes. Set -b. Run. Good. Break set -b eval. Continue. All right. Now we didn't. Something. I don't think I made. Run. Set break at eval. Continue. Okay. So 3 steps we can make for sure. Skip. Step. All right. And we're going to call str2 positive. Okay. Read x28. Global word not found handler. Wait a minute. I guess X0 is destroyed. What is going on with X28? Global word not found handler. We set it to this. Okay, I got a break here again. I'm sorry. Is it clear? Break set -b that. Run. Break set -b eval. Continue. Okay. Read X0. I think our test screwed something up. Yes, it did. Okay, we need to do that last in our setup. Okay, so this word not found handler thing was using x0 temporarily, which is supposed to point to the argument string to eval. So let's put that. Yes, make push the number data stack bus error 10. Okay, bang eval. No, what happened there? Run. Okay, I'm going to continue because we're getting a bus error, so it should point us somewhere directly. Eval REPL test eval plus 56. Store x19. That's eval. X19. Do I need to initialize VSP? I believe the answer is yes to both. I believe I did it. Yeah, so this points to push test stack, which has a 0 at the relevant thing. We point past. Okay. Let's see. What's going on here? Okay. A bus error. That sometimes is an alignment thing. Let's make sure. Let's do this 3. I think is a better choice. Not good enough though. Okay, bang LL. Breaks up minus B. This. Break. Continue. Run. Is it? Oh man. You're right. Thank you. Gosh. Good insight. Save me hours here. All right. So writes calls compiler in compile mode. Is that the right one? Push the number on data stack. Okay, so it does push the number on the data stack. Now, if we run, if we make a REPL, all right, 22, 12, add should be 34. Yay. Okay. Cool. So the make worked. The manual test also demonstrated it really worked. And eval pushes number on data stack. Yeah, woohoo. I mean, it'll feel different, you know? Okay. 6 minutes. We got the compiler one. Now that's more complicated. I don't know. Maybe we'll spend the last 5 minutes looking at the... Oh, no. Sorry, excuse me just a minute. Sorry about that. All right. So I think we did figure out what was going on because like you said, other tests write into this global handler, then each test that wants to use it needs to write into it. So we were relying on it, so we needed to do it. Okay. We initialize the dictionary and the stack because eval needs both those. Initialize the global handler because it's being used. Actually, I don't think we need it for this test, though. I think it was expectation that it would call that thing, which I think it did. It just called the local one because another test did it. But in real code, in our production code now, it should not be called. It should never be called at this point. So I think this should still run correctly. Yeah, that's looking good. Okay, so remove unneeded use of error handler in eval numeric test. That's good enough. Okay, so let's see. So go back to do. Numeric constants eval, that much is working. And then we'll pick up next week with compile. Okay, so it was needed because the code wasn't there, but it doesn't get called now. So next week we'll pick up here, numeric constants compile. So they're just supposed to, well, I shouldn't say just, they have to put in a reference to the push routine's word address, not the push routine's address, the address of the address, and then follow it with the constant that comes back from that string to positive thing. I still don't know if the relocatable thing, it seems like it's working, right? Because the real one calls that, did call it when we ran the REPL before we finished making that pass. It was calling the expected routine that says word not found. So then I don't know, maybe it works. I mean, I keep thinking it's not going to, but maybe my test was flawed earlier. All right. Well, it's been a good week. We've got the interpreter working. We got the compiler working for at least everything. Well, at least for words, that are primary or secondaries, words you define. And evaluation, direct evaluation works for numbers. Compiler doesn't yet. That puts us really, really in a great place for next time. I do think we'll spend the bulk of, probably the bulk of Monday, Tuesday. Well, we'll fix this first thing Monday. I may defer this too. Actually, it seems to be working, so let's just defer it. We'll fix as kind of an optimization to fix the stuff that already uses it. Okay, but we'll get these things done. The first half of them are just easy to bang out. The memory and control ones are going to be more work, but I think we can get there pretty far next week and have this little language basically working for numeric values. So we're up to basic circa 1963 or something. All right, so we're getting there. All right, well, have a good weekend. I'll see you Monday, 2 to 4:30 Eastern or 6 to 8:30 p.m. UTC. I don't know when, who has a time change this weekend, but I'm at least steady based on U.S. Eastern time at this point. All right, well, take care. Bye-bye.